Does the following series converge or diverge? We're going to be using the root test to test for convergence. And the reason why is because the root test is based on the limit as it approaches infinity of the nth root of your sequence. So if this is my sequence and I know that the root test consists of taking the nth root, then I can cancel these out. So basically, anytime you have like a huge quantity into the nth power, you will know that the nth root will cancel that out and it will just leave you with a of n. So it makes things easier. So this limit is going to be equal to a limit, or at Rutgers we call it rho. Even though it's a p, we pronounce it as rho. And the rules are if rho is less than 1, rho is greater than 1, rho is equal to 1. These are the same rules as ratio. This series converges absolutely, diverges, or the test is inconclusive, meaning try another test. So we're going to take the limit as n approaches infinity of the nth root of the sequence with absolute value. And because n is equal to 1, meaning that every term in our series is going to be greater than or equal to 1, so it's already going to be positive, then the absolute value of that is that. It's really no difference because it's already positive. And so because I see an n here and I see an n here, these are inverse operations and I can cancel them out and we're just left with the sequence. Isn't that beautiful? And then when we plug in n, we get 1 over infinity minus 1. Remember that one whole divided into infinitely small pieces gets infinitely smaller, so small it cancels out to be 0. So we have e to the 0 minus 1. We know that e to the 0 is 1, so 1 minus 1 is 0, and 0 is less than 1. So because rho is less than 1, that means that our series converges absolutely. So let's go to our conclusions. Since, and then we copy and paste the first limit that we wrote, but I erased it, so let me rewrite it, is equal to 0, which is less than 1. The root test implies that the given series converges absolutely, but the question didn't ask us if the series converged absolutely. It asked us if it converged, period. So this is where a number 2 tool in our toolbox comes in, the absolute convergence theorem, that says if we have any series that converges absolutely, which we do, we have a series here that converges absolutely, then that same series will converge. So we say, and absolute convergence implies convergence by the absolute convergence theorem, so the given series also converges. And that answers the actual question. This series converges.